Okay. That's no problem with that. So we'll remove that. Okay. We are live at JEC World, day one. And we're already into the afternoon. I'll tell you, the morning's flown by. But I'm very happy to have Steve Barbour of Composites Braiding. He is the managing director. And Steve, thanks for joining me on the podcast.
Thank you for the invite.
So one of the Innovation Award winners here at JEC World is demonstrating how composites can transform large-scale structure. Composite Braiding Ltd has developed a prototype composite twin-track cantilever structure designed to replace heavy steel supports used in railway electrification. The prototype composite twin-track cantilever was engineered and manufactured, of course, by Composite Braiding, and it not only demonstrates the viability of using sustainable composite materials in the production of high-volume railway infrastructure, but it also shows a clear environmental and economic benefit. So, Steve, again, thank you. Congratulations on being a Innovation Award winner.
Thank you very much.
That's a significant accomplishment. So, tell us a little bit, before we get into composite braiding, tell us a little bit about your background.
My background, gosh. So I spent 19 years at Rolls-Royce. My last two jobs were customer business director, looking after a lot of Europe, doing sales, commercial, customer support. And then I was head of marketing, and I was part of the team that got the Trent 1000 selected on the Boeing 787.
Right.
Then a friend of mine asked me if I wanted to come into the composites world, and I joined into composites, running a composite manufacturing operation. I was the ideal choice for that, apart from two things. One, I'd never run an operation, and two, I knew nothing about composites. Having said that, that's now 21 years ago.
Right.
And since then, I've done 4 composite manufacturing turnarounds, 3 in the UK and 1 in South Africa, and then started up my own composites business, Composite Braiding Ltd.
That's amazing. Wow. What an accomplishment. So from no experience to...
and some would say that's still true.
Well, what's the old saying, Henry Ford? I don't have to know everything. I have to know the right people, right?
Correct. Yeah, I've got a great team.
You got to have a great team. Exactly. So tell us about this project, the cantilever. Are these typically seen cantilevers, composite cantilevers? I mean, these aren't traditionally composite parts, but is this something new that you all have developed?
It is. So we'd had a lot of the UK rail network people, tier ones, civil engineering guys, etc., come into the factory. This is absolutely fantastic what you guys do with your technology, because we do high volume, lower cost structural composites. And so they were saying it'd be great to see this on the railway, and we're going, it's great.
Yeah.
And it was brilliant. But I'll tell a little story. So I go to my supermarket on a Friday, and in the evening I'm there at the checkout with my weekly grocery.
Right.
And I go to the person at checkout, excuse me, say, can I pay you with enthusiasm? And they say, no, we'll take cash or check, please. So
nice try.
So yeah, nice try. So basically, it was fine having the enthusiasm, but we were looking for a catalyst to actually go and do something physical and go and produce something. Anyway, there was some funding through a particular program called Clean Futures. It was looking at rail infrastructure, how to reduce carbon footprints, how to reduce steel and concrete. And so we applied for that. We were fortunate to get on. We then got support from 4 major tier ones in the UK who supply into the rail industry. One of them in particular, Amy, was installing steel, galvanized steel overhead line structures. A twin track cantilever, just put into English, is it like an inverted L. It's 8 meters tall, 4.5 meters wide.
Right.
And it holds a couple of very high voltage lines in place, 25,000 volts. And so they're very structural. And so they gave us some drawings, some load information, said, could you do this? And we looked at it and said, yeah, we can. And so we set about actually then designing, manufacturing and installing a twin track cantilever. And that's how that came about. It was basically to act as a catalyst. Now, there's a whole bunch of stuff we can do, but we started at the highest loaded structure they were installing.
Right.
So we wanted to start at the hard end, and then we know that anything else is doable.
Absolutely. You've proven it out at the top of the line.
Correct, yeah.
So so how scalable is this process moving forward?
So to put it into context, in terms of the beams that we're making, we can make them several meters long, and we can consolidate them, so that's adding the heat and the pressure, in about 10 minutes. And typically we're using somewhere in the region of 95% less energy than you'd use if you're using in an oven. Wow. So it's very, very scalable. We can do very, very high volumes.
So your process, the braiding, what makes this such an effective process for a large component like this?
So in terms of braiding, the actual process of braiding itself obviously is something that many people can do with a braiding machine. Sure. It's just tubular weaving. In terms of what we do is we're using typically commingled material, and we've developed a consolidation process that allows us to be able to consolidate those parts very, very quickly and very energy efficiently. And it's the combination of both the braiding and the consolidation that give us an end-to-end process, which is really truly different.
Yeah. So you've this has been tested, verified. I mean, what's the next step of the process?
So we're now working with some of those tier ones, and we're going through qualification processes with potential end users, looking at the mass rollout of this to become hopefully now a new standard of OLE. It's been described by the tier ones as being game changing. So we're really wanting to work with those guys to actually literally change what's out there in the railways. But it doesn't just apply to railways. This is any structural tube or beam.
Well, that's what I was going to ask. You know, what beyond railway, what are some other areas, some other industries that this could be applied to as well?
Gosh, we're working in aerospace, in automotive, logistics, sports, a whole range of different industries, because really what we've become is an expert in thermoplastic composite braiding and how we go match the mechanical requirements of whatever a customer's looking for. So it's really more down to us working with people who understand their markets, understand what they want, and we can then help them to engineer exactly what they need.
What's the conversation typically that you have when somebody brings a project to you, and maybe that's outside of railway?
So typically it's going to be them coming in with a particular problem. So we've met in some way, shape or form. They've got a problem. My first conversation is to understand whether we can add value to that end customer. Because there's no perfect material and process that does everything. And so whilst I'd love everything in the world to be thermoplastically braided, because then frankly, Jeff Bezos, you're going to have nothing against me. But in reality, obviously, we're first of all finding out, can we really add value to that end customer? If the answer is yes, then we can go through a proper gated process to go and qualify our capability for that customer and that requirement.
I'm going to showcase the website. Our listeners or people that are watching can find it at compositebraiding.com. And also you can find, streaming down at the bottom, if you're over at Hall 6, that is T62. I need my reading glasses. T62. Stop by and pay them a visit. What can they, if they go over visit your booth, what will they find over there? And
first of all, a very warm welcome.
Yes, right.
And there's actually some free coffee on the CK stand, so that's good.
Can't get enough of that at the show.
We've got a few of the samples across there, so again we can explain what it is that we do. But as we do some quite large structures as well,
of course,
then obviously there's a limit as to what we can have on the actual stand. However, if you then go to the Innovation Planets in Hall 6, you can actually see within there a smaller section of the twin track cantilever. It's actually it's about 3 meters tall as opposed to 8 meters. It was a bit too big to get in my bag otherwise. So effectively, we've got something in there that gives you
through TSA, right?
You're right. So basically, you get a bit of a sense of what it is that we're doing.
Well, congratulations again, Steve, to your team. Amazing work. And, I look forward to hopefully following up with your success and meeting again soon in the future.
Okay, I look forward to it. Thank you very much.
Thanks again.
Thank you.
It's great.